Hey, chemistry. So we are going to take a minor step backwards before we move forwards, past the quiz, right? Quiz day was today. It was pages 6 through 10. Those grades went up pretty quickly. It's much easier to grade multiple choice stuff, so those grades will go up very, very quickly. I'll get those back to you the next time you're in class. Um, if you missed class, if this is just a generic statement, if you miss class on a quiz day in particular, rather than having you come in the next 10th period, because I have lab 10th period, it's not always like a quiet environment. However, I figure you can make yourself a small quiet environment at home. So what I will probably do, let's say you are a group 1 Lasallian, right? So today was Monday, you would have come into school today, but you were sick. What I will do is on your remote day, you will receive an email from me at about 8:30, 8:45 a.m. It will be the quiz. I would like that quiz back to me no later than, I think I said 1 o'clock. I put it in the announcements. I actually put stuff in the announcements, guys. But I put it in the announcements. Get it back to me no later than 12:30 or 1 p.m. I think I said 1 p.m. Um, Uploaded to the appropriate assignment on my CBA. All of the assignments on my CBA have online submission. It's primarily for fully remote students. However, I will utilize it for any hybrid model students who miss class but have an assignment to do in class, typically a quiz. If it's a quiz, I'll probably do it because it's fairly short. It's not a ton of points, and I trust you to create a quiet environment, use a reference table. There is a reference table on my CBA, so just go to the my CBA page, click on it so you can see it. You have access to a calculator. You can complete that, right? Create an environment in which you can take the quiz, upload it to the assignment, and I can have it graded that day. That way I don't have to chase you down 10th period or give you a pass, hey, come in 10th period, because I can't guarantee a quiet space, right? I want you to have the same environment that your classmates had, and it feels like a fair way to do that. Just letting you know. If you are a brother, right? If you're in group 2 and you miss quiz day, what I'll do is your next remote day. So let's say that you're set to take the quiz tomorrow, but you're sick in the morning, a sibling is sick, you can't come to school for whatever reason. It's okay. What I'll do, again, for your next remote day, I may try to do it tomorrow. I might try to check attendance, but attendance is not always updated quickly. That was weird. I was monologuing. Attendance is not always updated quickly in the mornings, so I will probably wait until your next remote day. This is despite whatever I said in the announcement. I will probably just update the announcement to reflect this appropriately. Now, after the quiz, on quiz days I typically don't have an agenda. However, it occurred to me that I know I had to come back to page 4. Page 4, this is on the calculation section. We were doing sig figs and such, and we ended here with these examples, and I said I'll come back to percent error with a lab. The Summers and I are still trying to figure out exactly how to do in-person labs, or at least on some level. Right now it's not super feasible working on it. I have a lab that I like to just introduce and do this with, but in the meantime, so that you have the notes and you can do example questions, I don't have to limit myself in the types of questions that I can ask. Percent error is a calculation that you can make. So when we take a measurement and we compare it with its accepted or its actual value, we can do so by calculating the percent error. All right. Now, percent error, you should see that there's an equation just here. Percent error is measured value minus accepted value over accepted value times 100. This is on your reference table. It's nothing that you need to memorize. All right. So, for example, here, calculate the percent error of experiment. Your experiment measures 10 grams of product, so that's the measured value. The accepted value, it's fairly straightforward. They may say given value, they may say accepted, they may say actual, but they all mean the same thing. It's what it's supposed to be, what we know it is actually, right? This here is right. I just want to show you what this is going to look like. So when you do this percent error, One thing to make sure of is that you do that subtraction up top first. Then remember that these are going to cancel because they're the same unit. So this is 0.25 times 100%, which means that we have 25% error, which is precisely the same thing that it says here. It is possible to get a negative percent error, as little sense as that makes, just because whatever you measured is really smaller. So you can be percentages wrong positive. You can also be like percentages wrong negative. Ideally, there would just be absolute value signs up here. For whatever reason, New York State doesn't like absolute value signs. They think that you want to do math with negative numbers. I don't, but it is what it is. Now, these two questions here, I would like you to try after we do these couple of examples. Then I'm going to give you some rounding rules too, because this was a nice number, right? You measure a mass of 12 grams, but the sample is listed to be 15 grams, all right? So percent error, I've already set it up. 12 grams is your measurement. 15 grams is the actual value, and then times 100%. So when I do this, I'm going to get negative 3 grams over 15 grams times 100%. All right, so grams are going to cancel again. So I have negative 0.2 times 100%, which is negative 20%. So I was off by 20%, but I was too small, right? Instead of being too big 20%, I was too small 20%. That's okay. The last example that I have is that you measure a density of 6.7 grams per milliliter, and the accepted value is 6.6 grams per milliliter. So percent error is here, right? I do my math, I get oh goodness, I was doing so well right up until then. There we go, 0.1 grams per milliliter over 6.6 grams per milliliter times 100%. Right? If I do this math out, I get 0.01515 blah blah blah. It just keeps going, right? It's a never-ending decimal. Again, times 100%. Oh goodness. So when I do this, I get 1.51515 blah 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 percent. I don't want all those numbers. I also don't want you to... I kind of want you to rely on sig figs here, but there may be a discrepancy in numbers. Typically there isn't. We're going to use sig figs. So look at this. Look here. The density is 6.7 grams per milliliter. If I look at this number, there are two sig figs. 6.6 grams per milliliter. Two sig figs. Percentages. This 100%. It is not considered a number that's part of our measurements. It's an exact thing. So I don't look at that. I do not look at percentages when I consider sig figs. So ignore this. This was 2 sig figs. This was 2 sig figs. Let's take this answer and round it to 2 sig figs. Well, that's easy enough. That means it's 1.5%. That's a very good error percentage, by the way. I'd like it to be basically 10% or below. Below 10%, I feel pretty good about it. 20, 25%, that may be more realistic given the limitations of measurements, given the limitations of equipment, but I'd like it to be small. Now, there are 2 questions here. You should notice that the first one has 4 sig figs. The second one has 3 sig figs. So round to an appropriate number of sig figs. Everyone will do these questions. Everyone will take a picture of this. Either, have the page in front of you, take a picture of the page, or write it on another piece of paper, take a picture of that piece of paper. Upload it to the assignment. Okay? Please upload it to the assignment. Don't email me questions. You can email me with questions, but don't email me the answers, because it's very easy for those emails to get lost in the shuffle of any number of emails I'm getting. I feel like we're all inundated with emails. So please upload it to the assignment. It's very easy for me to see in the gradebook whether you have submitted or something or not. Then I can look at your submission and just glance over it and see that it is done correctly. If it's not done correctly, I may comment on it, just to give you a little feedback. But there we are. When we get back, on your next in-person day, we will continue with the next small section of notes, which is more about atomic structure. It's about some of the atomic models that we have, and what we think the atom looks like now. All right? That's all for today. We'll see you next time. Take care, kids.